You ever wonder what's really going on inside the quote-unquote mind of an AI? I mean, we see it everywhere, right? Does incredible tech that just feels like magic. Well, today, we're going to pull back that curtain and show you the engine that makes it all run. I mean, just think about it for a second. Self-driving cars weaving through traffic, Alexa somehow understanding what you want, ChatGPT writing a whole poem. It all seems so impossibly complex. So, what is the secret sauce here? What's powering all of us? Well, it's not some kind of magic. It's math. Yep, that's it. The brain of every single AI, the engine behind every smart decision it makes, it isn't some mysterious ghost in the machine. It's just math. Pure, structured, and unbelievably powerful. Okay, so let's peek behind that curtain. Because here's the thing. At its very core, AI isn't just built on fancy code. Nope. Every single prediction, every pattern it recognizes, every chatbot reply you get, it's all the direct result of a mathematical model doing its job. And this is a perfect way to think about it. You can have the most powerful computer hardware in the world, the most elegant code, but it's all just an empty shell without the mathematical logic to guide it. The math, that's what provides the intelligence, the actual ability to reason and to learn. Okay, so if math is the brain, then what are the different parts that make it tick? Well, it turns out AI really leans on this powerful toolkit of 5 key areas of math. So let's break them down one by one. All right, here they are: linear algebra, calculus, probability and statistics, optimization, and graph theory. These are the big 5. Now, let's see what each one actually does. So first up is linear algebra. The best way to think about this one is as the great translator. See, an AI can't see a picture of a cat the same way you and I do. Instead, it sees this giant grid of numbers. That's what we call a matrix, and each number is just a single pixel. Linear algebra is the tool that organizes all that numerical data so that AI can actually understand and work with it. It's not just an analogy. It really is the native language of AI. Absolutely every piece of data, doesn't matter if it's an image, a sound clip, or a block of text, it all has to be translated into this structured grammar of vectors and matrices before the AI can even begin to make sense of it. Okay, so if linear algebra gives AI a language to understand the world, calculus is what gives it the ability to learn, to get better over time. It uses this really cool process called gradient descent. Just imagine a hiker trying to find the absolute lowest point in a valley, in the dark. They'd feel around with their foot and take a small step in the steepest downward direction, right? Well, that's exactly what calculus helps the AI do. Take these tiny, smart steps to minimize its errors and get closer and closer to the right answer. And that's why we call it the engine of learning. It's this constant process of tweaking and refining, always pushing the AI model to get just a little bit more accurate with every single attempt. But, the real world is messy. It's full of uncertainty. And that's where probability and statistics are absolutely crucial. These are the tools AI uses to make educated guesses. For example, when your phone predicts the next word you're about to type, it's not reading your mind. It's just using statistics to calculate the most probable word based on patterns it's learned from billions of sentences. That's why it's the backbone of its decision-making. Because really, almost every decision an AI makes is a kind of calculated bet. Whether it's recommending a movie or flagging a credit card transaction as suspicious, the AI is using probability to weigh all the options and pick the path that's most likely to be correct. It's the very foundation of how it reasons.
Right, but finding just any solution isn't good enough, is it? For AI to be useful, it needs to find the best possible solution. And that's where optimization comes into play. Think about Google Maps. It doesn't just find you a route, it finds you the absolute fastest route, factoring in real-time traffic, road closures, all of it. That's optimization in action, making AI practical and, useful.
And last but not least, we've got graph theory. This is basically the math of networks and connections, how different things relate to each other. It's absolutely perfect for understanding complex webs, like your circle of friends on social media, or how all the pages on the internet link together. AI uses graph theory to spot those hidden relationships and patterns that you'd never see just looking at the surface.
Okay, so that's all the theory, but I want to be clear, this is not just some abstract math you'd only see in a classroom. You are interacting with all of this stuff every single day. So let's look at a couple of real-world examples. Okay, let's start with unlocking your phone with your face. We do this all the time, right? The moment your camera sees your face, it converts that image into a matrix, a grid of numbers representing your unique features. Then, linear algebra jumps in and compares that new matrix to the one that's stored in your phone. If they match, boom, your phone unlocks.
That simple, everyday thing, that's pure linear algebra at work.
Or how about Netflix recommendations? This is a great one. So when you watch a show, graph theory gets to work, mapping your tastes and connecting you to a whole network of other people who like the same stuff you do. Then probability and statistics step in. They calculate the likelihood that you'll enjoy a movie that all those other people in your little taste network also loved. And just like that, your next perfect recommendation pops up. It's an amazing example of how these different math tools team up. You know, when you see it all laid out like that, it really changes how you look at AI, doesn't it? I mean, yeah, the algorithms and the lines of code are obviously important, but the real power, the actual intelligence, that's coming from something else. So, the next time you use Google Maps or chat with an AI bot or get one of those scarily accurate recommendations, just remember what's going on. You're actually witnessing this beautiful symphony of mathematical principles all working together quietly in the background.
So yeah, maybe we can forget about the flashy robots and the endless lines of code for just a second. These guys, linear algebra, calculus, probability, these are the real superheroes of AI. They're the unseen force that is literally building our future. And that kind of leaves us with one final thought to chew on. Now that you know the secret behind AI isn't really a secret at all, it makes you wonder, right? What other magic in our world, what other amazing technology is really just the beautiful, powerful language of math working in disguise?